Ever wonder if there's an easier way to complete transactions without having to deal with online wallets, banks, and third-party applications? Well, it's possible thanks to blockchain. Here's everything you need to know about blockchain. Imagine 4 friends, Jack, Ted, Sam, and Phil, meet up for dinner. After they're done, Jack pays the bill, and all of them decide to split the expense amongst each other. Now, on the next day, when Phil sends his share to Jack via online money transfer, the transaction goes through without a hitch. Then, Ted and Sam send their respective shares to Jack, but their transactions don't go through. The failed transaction cites some issues at the bank. That's when Jack comes to know about the many ways a bank transaction could fail. It could be due to technical issues at the bank, one of their accounts were hacked, daily transfer limits being exceeded, and sometimes additional charges, like transfer charges, associated with transferring money. To solve these problems, the concept of cryptocurrency came into existence. Cryptocurrencies are a form of digital or virtual currency that run on a technology known as blockchain. Thanks to blockchain, cryptocurrencies are immune to counterfeiting, don't require a central authority, and are protected by strong and complex encryption algorithms. And in a market of more than thousands of cryptocurrencies like Litecoin, Ethereum, Zcash, and so on, one reigns supreme: Bitcoin. Now, let's go back to our previous example and have Phil, Ted, and Sam send Jack 2 Bitcoins each as their contribution to the previous night's dinner. Let's assume Phil, Ted, and Sam have 3 Bitcoins in reserve, while Jack has 5. First, Phil sends 2 Bitcoins to Jack. A record is created in the form of a block. The transaction details between them is permanently inscribed in this block. This record also holds the number of Bitcoins each of the friends own. So, after Phil's transaction, Jack has 7 Bitcoins, while Phil has 1. Following this, Sam and Ted send 2 Bitcoins to Jack. A new block is created for each of these transactions. These blocks hold the transaction details as well as how many Bitcoins Sam, Ted, and Jack have in reserve. These blocks are linked to each other, as each of them takes reference from the previous one for the number of Bitcoins each friend owns. This chain of records, or blocks, is called a ledger, and this ledger is shared among all the friends, which acts as a public distributed ledger. This forms the basis of blockchain. So, what happens when Phil has only 1 Bitcoin left, and he tries to send 2 more Bitcoins to Jack? The transaction will not go through. This is because all his friends have copies of the ledger, and it's clear that Phil has only 1 Bitcoin left. His friends will flag this transaction as invalid. A hacker will not be able to alter the data in the blockchain because each user has a copy of the ledger. The data within the blocks are encrypted by complex algorithms. All of this is made possible with the help of blockchain technology. Blockchain can be described as a collection of records linked with each other, strongly resistant to alteration, and protected using cryptography. Now, let's have a closer look at the Bitcoin transaction between Jack and Phil and find out how it works. Every user in the Bitcoin network has 2 keys, a public key and a private key. The public key is an address that everyone in the network knows of, like an email address of a user. The private key is a unique address that only the user has knowledge of, something like a password. First, Phil passes the number of Bitcoins he wants to send to Jack, along with his and Jack's unique wallet address through a hashing algorithm. All of this is part of the transaction details. These details are encrypted using encryption algorithms and using Phil's unique private key. This is done to digitally sign the transaction and to indicate that the transactions came from Phil. This output is now transmitted across the world using Jack's public key. With this, the message or transaction can be decrypted only by Jack's private key, which only Jack has knowledge of. Different cryptocurrencies use different hashing algorithms. While Bitcoin uses the SHA-256 algorithm, Ethereum, which is also a famous cryptocurrency, uses one known as Ethash. This transaction and several other similar ones are taking place all around the world. These transactions are validated and then added block by block. The people who validate these blocks are called miners. For a block to be validated and added to a blockchain, miners need to solve a complex mathematical problem. The miner who solves this first adds the block to the blockchain and is rewarded with 12.5 bitcoins. The process of solving the complex mathematical problem is called proof of work, and the process of adding a block to the blockchain is called mining. With this, Phil and Jack's wallets are updated, just like every person in the network who has completed a transaction. Now that you know about blockchain and its important concepts, time for a small quiz. What is the concept of blockchain that ensures data cannot be altered by any of the users within the network? A. Public distributed ledger. B. Proof of work. C. Proof of stake. D. Hash encryption. Let us know what you think is the right answer in the comments below. 3 lucky winners will get Amazon gift vouchers. Details are mentioned in the description below. Let's have a look at how Walmart uses blockchain to provide its customers with better service. Walmart was facing problems in delivering quality products to its customers. They were facing a high return rate and large amounts of refunds due to their products' bad quality. They were unable to determine the point of failure in the supply chain, which started from farm to storage to transportation to processing all the way to the customer. Then, Walmart adopted blockchain technology. With blockchain, the quality of the goods at each step was permanently inscribed within a block. For example, when a customer flags a product as damaged, it can be correctly identified where the product got damaged in the entire supply chain, thus helping Walmart to identify the problem areas and fixing them. And this is just one of several ways blockchain is used in real-life applications. Can you think of any others? Let us know in the comments down below. That's all for now.
Now, what are the current set of issues in today's banking system? In order to do any transaction on a banking channel today, it costs a very high transaction fees. So suppose you want to do a transfer of money from your account to someone else's account through a banking channel, the bank might charge a fee for a $200 transaction up to $5, and the receiver will end up receiving $195, which in percentage terms is a very high percentage of transaction fee. Also, as of today, there's a lot of scenarios people end up doing double spending. For example, over here, the user has $800 in her account, but she ends up sending $1,000, $500 each to 2 users. Double spending is a unique problem where digital money is spent twice. So what does it tend to do is the user is able to make 2 purchases with the amount which is less than the purchase value. So in this scenario, the lady was able to buy a commodity worth more than $800, though she only had $800 in her account. Also, the banking systems are prone to hacking. Hackers attack financial institutions and gain unauthorized access to data. They can do transactions on your behalf which you are not aware of, or they can do the transfer of money to some illegitimate accounts. In 2017, the number of frauds in India through ATM cards and net banking totaled to 1,785, each amounting to more than 1 lakh rupee. So if you see, the current banking system is prone to so many hacks that it can amount to huge cost of money. Now, how Bitcoin can solve these problems? Now, Bitcoin is a decentralized system, so which allows you to do a value transfer transaction at a lower transaction fee, as low as $1 as compared to the $5 which the bank was charging. And at the end, the receiver receives the true value of the amount which was sent by the sender. Bitcoin follows a decentralized system where no third party like governments, banks, or any other financial intermediary is involved during the transaction between the sender and receiver, thereby reducing the cost of transaction drastically. And that is the primary objective of cryptocurrencies or technologies like blockchain, which advocates the removal of intermediaries. Now, Bitcoin is a cryptocurrency that runs on blockchain. Now, how Bitcoin solved the problem of double spending? Double spending is avoided through the basic structure of blockchain, which involves verification of transactions. So in the previous example, as we saw, when the user transferred $500 to the first person, then she will not be able to transfer the another $500 based on the basic validation of the blockchain, and we will see how. So suppose you're trying to spend the same Bitcoin in a second transaction. After the first transaction has been confirmed, the second transaction will not get verified and thus become invalid. And this will happen because after the first transaction has been confirmed, your balance will be verified in the second transaction, your address identity will be validated, and if suppose you're trying to spend more than what the balance you have, the miners, the validators of the blockchain network will discard that particular transaction and will not add it to the main blockchain network. Thereby, double spending becomes as good as impossible. In a blockchain, each block is linked to its previous block. The transactions become invalid for a specific Bitcoin which has already been spent. So you can't spend the Bitcoin which you have already spent. Public ledger. A public ledger records all Bitcoin transactions where it is accessible to everyone who is associated with the system. It is a 100% transparent system. Any transaction happening is visible on the public ledger. Once a user joins the blockchain network, he gets a copy of all the blockchain transactions since its initiation or inception. And the first block in a blockchain is called the Genesis block. Though the public ledger is accessible to everyone, only the user's address and the transaction details are visible to the users on the Bitcoin network. By looking at the address, you can't figure out to whom this address belongs. The identity is secure of the address owner. This keeps blockchain safe from data tampering. Each block on the blockchain is aware of who is its previous block, and this way the entire blockchain is created. Even if a hacker tries to hack one block, it would have to change the entire subsequent chain ahead of this block, which will require huge amount of computation power for the hacker in order to make the changes across all the blocks, which is next to impossible. Now, what is blockchain? Imagine two friends living far away and would like to transfer money using blockchain technology. Blockchain is a decentralized system of secure and trusted distributed databases. It's a distributed ledger which records and shares the transaction details across many nodes which are part of the network so that the data is not modified. So each and every transaction which happens on a blockchain network is distributed across all the nodes on the blockchain. Each and every participant has the same copy of the ledger, and it's an immutable ledger. Once a record or a transaction is registered, it cannot be modified. Blockchain was originally introduced to timestamp digital documents and prevent tampering of records. In simple terms, a chain of blocks that contain information is called blockchain. Now, when a transaction occurs, its related information is recorded into a block. So as you see, a transaction initiated in one corner of the globe can get registered on the block, and then that block is being verified, validated by the miners of the public ledger, and then added to the main blockchain. A block contains aggregated transactions in a single block which a miner has to validate, and in lieu of that, the miner gets rewarded. Now let's take a closer look at what all are the components of a block. So whenever we talk about a blockchain, what is actually a block and what it consists of? Now there are four major components. Each block contains a previous hash, data. Data is nothing but the aggregation of the transactions which are aggregated in the block, a nonce value, and the hash of the block itself. Now what is previous hash? Previous hash is the attribute which is connecting a block to its previous block. So the previous hash attribute consists of the hash value of its previous block. Data, it consists the details of the sender's address, the receiver's address, and the transaction amount. So basically there could be multiple transactions amongst multiple senders and receivers. So each block will consist n number of transactions, and each transaction will have a sender's address, a receiver address, and a transaction amount. Nonce, so basically the Bitcoin uses a proof of work algorithm, and in order to execute the algorithm, nonce is a random value used to vary the output of the hash value. So proof of work is the process of transaction verification done in blockchain. Hash is like a digital fingerprint. It is the fingerprint of the current block. Now where it takes an input value of the previous hash, the data and the nonce, and produces an output value of fixed length. So Bitcoin network uses SHA-256 hashing algorithm to generate a 256-bit length hash. And this is the output. It looks something like a hexadecimal value. Now what are the features of blockchain? A blockchain is a decentralized public distributed ledger that is used to record transaction across many computers. So this is a sample transaction which you are seeing. These are a set of 3 transactions: A transferring money to B, B to C, and C to B. A distributed ledger is a database that is shared among all the users who are part of the blockchain network. The transactions are accessed and verified by users associated to the Bitcoin network, thereby making it less prone to cyber attack. It is actually enclosed within all the participants who are part of the network. Now let's take an example where these Bitcoin users are transferring money. So here we have example like Bella is trying to transfer money to John, John is trying to transfer money to Elsa, and Elsa is trying to transfer money to Jack. So these are the 3 transactions which are to be initiated. Now suppose these transactions were being happening on a central ledger and it gets corrupted. So there is a chance of the data getting tampered. To solve this problem, a public distributed ledger plays a vital role. Now it ensures that users part of this cycle have a copy of the transaction details. Each user will have a copy of each transaction. Bella, John, Elsa, Jack, they all have the same ledger, and this is what is called as distributed ledger. Everyone is having the same copy. Now in case one of the users like Elsa misplaces her transaction detail, she can easily be corrected by the other participants because they have the golden copy, the correct copy. Or if either of them attempts to alter the record, the alternate transaction copies with the other users will negate the alteration, because they will see that amongst all the participants only one participant is having a different copy. They will negate the copy of the user and they will rectify it. Encryption. Blockchain eliminates unauthorized access by using cryptographic algorithm SHA-256 to ensure that the blocks are kept secure. So SHA-256 is the cryptographic algorithm which is used. Each user in the blockchain has their own keys. So any user which onboards a typical blockchain network is always provided with 2 sets of keys. One is private, one is public. Private key is known only to the sender. Also, it is used to confirm if the origin of the transaction is legitimate. Public key, it is also used to uniquely identify the user, but it is shared by the sender with every transaction it floats on the blockchain network, and we will see how. Now let's take a look at a typical transaction verification process. Suppose a sender wants to send a message. He will pass the message through the hash function and generate a hash value of the message. Now, after the hash value is being created, it is passed through a signature algorithm, and with the private key, a digitally signed document is created. Now, the transaction message, original message, the digitally signed document, and the public key are transmitted to the receiver. Now, at the receiver end, the transaction message is passed through a hash function to get a hash value, and that hash value is compared with the hash value obtained by passing the digital signature and public key through a verification function. And then both the values are compared. Now let's see how the hash function works. The hash function creates a unique digital fingerprint of data. You pass the message through the hashing function and it generates a hash value. This hash value is called a digital print. It has a very unique property. Any hashing function is a one-way function. It cannot be reversed. You cannot decode the original value from the hashed value. It is a one-way encryption. So here are some examples. Whatever be the size of the input data, the hash value is always of 256-bit length. And we will take a look at the demo at the end of this session, where I'll show you how to generate a hash value using SHA-256. Now let's consider an example of Gmail using hashing algorithm. Whenever you are entering the username and password, that password is never directly persisted in any of the Gmail's database. It is persisted using hashing function. So once you have created your password, and again once you log in, your password is again passed to the hashing function and compared with the hash value persisted in the database, and once both these hash value matches, then only you are allowed to log in. So every time you log into Gmail, your password is hashed, into a value and compared against the one stored in the database. The hash value is matched with the one in database, and then the inbox is displayed on your screen. Now let's take a look of what is the proof of work algorithm. Proof of work is a method to validate transactions in a blockchain network by solving a complex mathematical puzzle, and this whole process is called mining. Finding the nonce value is the mathematical puzzle that users or miners need to solve in the Bitcoin network. So it takes huge amount of computational power and resources of the miner in order to find out that nonce value. Users trying to solve the puzzle are called miners. The puzzle is solved by determining a nonce that generates a hash value and results an output lesser than a target. So in any proof of work algorithm, there is always a target which is predefined for a block. The miner has to use the nonce in order to generate a hash which has to be less than the target. Miners verify transactions within a block and adds the block to the blockchain when they have confirmed and verified the transaction. With proof of work, miners compete against each other to solve the mathematical puzzle. The first miner who solves the puzzle is rewarded. And when a block is solved, the transactions contained in a block are also considered valid, and the bitcoins associated with the transactions then get deducted from the originator or the sender and moves to the receiver. Now let's see how proof of work works. So let's take a look at the block and its components. The previous block hash, it stores the hash value of the previous block of the blockchain. Data, it contains the list of all the transactions which have been aggregated in the block. Nonce is the random value which is used to generate a hash value less than the target, and hash is the digital signature of the block itself. The hash is generated using a hashing function called SHA-256. Now, using the nonce, when the hash is generated, if its output is less than the target, then the puzzle is deemed to be solved. The block is considered to be validated. If not, then the miner increments the nonce by value 1 and then again rehashes, generate a hash, and goes through the cyclic process till the time it is not able to generate a hash less than the target. In blockchain, the target is adjusted every 2016 blocks, which is approximately every 14 days. The average time of block formation is 10 minutes, and the difficulty target of the puzzle increases or decreases depending on the time it takes to mine the blocks. So it is the inbuilt network which is generating the target for the puzzle to get solved, and it fluctuates the difficulty based on the time it takes to mine the block. Proof of work is hard to produce but very easy for miners to verify. So point to be noted here is, once the block is hashed, the remaining miners are supposed to validate the work which one miner has done, but they are not required to find the nonce again. So basically, the miner who is supposed to earn the Bitcoin has done the hard work, but the others miners on the network just have to verify his validation. In blockchain, when miners use their resources, time, money, electricity, etc., to validate a new transaction and record them on the public ledger, they are given a reward. Now that reward is in Bitcoins itself, which as of today stands at 12.5 Bitcoins. And to add, there is no other way that the Bitcoins can be generated in a Bitcoin network. It is only through mining. Now, the Bitcoin network internally halves the reward after every 21k blocks, which is approximately every 4 years. So now subsequently, whenever the time period will end, the mining reward will get reduced to 6.25 BTC. Now let's take a look at a demo. Now, as I said, this is a demo to showcase how to generate a SHA-256 hash using an input value. So whatever input I have, the hash which is generated, it is of 256 bytes. Even if I add a new value, it will again only generate a 256 bit length hash. Now let's take a look at a typical blockchain structure. We have a block over here which has one transaction added to it. Now this is orange in color because it has not been mined, and I can only add a subsequent block to it once it is mined. Now as this is the first block In this particular blockchain, the previous hash value of this block is all zeros, and it is called as a genesis block. Now, as I have mined this block, the hash, which is the digital signature of this block itself, has been generated, and I can now add a block. Primary thing which to be noted over here is that the previous hash value of this new block is the hash value of the previous block. It has two transactions aggregated in it, and I can again mine it, and now the hash of this block has been generated. So this highlights the typical data structure of a blockchain and how blocks are linking themselves to each other. Now let's take a look of a typical transaction which happens over a blockchain. Now I want to send money from wallet 1 to wallet 2, and I want to send $1. There is a transaction fee of $0.1 associated with this transaction. Now as I have initiated the transaction, wallet 1 has been deducted as $1.1, and it is a pending transaction. This transaction is waiting to be mined, so I can choose any of the miners to do this transaction. The pending transaction is done, and now block 2, if you see, has been added. The previous hash value of this block is 00A9 is the hash value of block 1. Another thing to be noted, the value of the amount in wallet 2 has also got incremented by $1. Again, we can try another transaction, transferring $1 again from wallet 1 to wallet 3, and say from wallet 2 to wallet 3 I have done a transaction. It is pending, it can be mined, and block 3 has got added. Now what are the key takeaways today? We learned what are the current issues in the banking system and how Bitcoin solve them, what is blockchain, features of blockchain, and a demo of the features which we have seen.
Hyperledger. Hyperledger is an open source collaborative effort created to advance cross-industry blockchain technologies. It is a global collaboration hosted by the Linux Foundation, including leaders in finance, banking, Internet of Things, supply chains, manufacturing, and technology. It is a framework to create, deploy, and maintain blockchains for businesses that ensure accountability, transparency, and trust among business partners. As a result, Hyperledger makes business networks and transactions more efficient. Concept of Hyperledger. Now, before I tell what Hyperledger is, let me tell you what Hyperledger isn't. Hyperledger isn't a blockchain, a company, or a cryptocurrency. Hyperledger is a software used to create one's own personalized blockchain service. It is basically a project within the Linux Foundation, just like several other projects under them, which include Node.js, AllJoin, DroneCode, and Akumos. Since it is open source, people across the globe can come and help develop and grow the platform. Restrictions in public blockchain. With a goal in mind to develop an enterprise-based blockchain platform, developers started testing interactions between applications and secure blockchains and realized that public blockchains require each peer to validate transactions and run consensus. This is a major challenge when it comes to scalability. Moreover, the transaction confidentiality and privacy was also getting lost as every node in the network was receiving a copy of the ledger. Private and confidential contracts. Let's consider an example. A certain bank is giving better privileges to its premium customers, for instance, in credit cards. Thus, if I am a premium customer of the bank and have been banking with them for quite some time, then it will give me a better offer on credit cards or will give me a loan at discounted rates. These things are common in the banking world. However, if these banks start using public blockchains which have complete transparency, disparity like these will become evident. Moreover, there is an issue with regards to competition. All banks are competing with each other in order to create a better place for themselves in the market. Thus, they want their confidential information about transactions and other operations to stay completely confidential. This won't be possible in a public blockchain like Ethereum, which stores all smart contracts on public ledgers. This is where platforms like Hyperledger come into the picture, which permits permissioned and private transactions, and it is highly scalable as a platform. Solution to the restrictions. On Hyperledger Network, only parties directly related to the transaction deal are updated on the ledger, thus maintaining privacy and confidentiality. Hyperledger primarily leverages the concept of channels to ensure privacy and confidentiality. A channel is basically a virtual blockchain network which sits atop a physical blockchain network and has its own access rules. They employ their own mechanism for transaction ordering and thus ensure scalability, thereby permitting effective ordering along with the separation of data. In the above example, when John and Kat are conducting a transaction, a private channel between them serves as a method of interaction. The smart contract can thus be viewed by only these two parties, and the network's endorsement policy verifies their membership with the network to ensure privacy. Thus, the transaction is secured and private and confidential. Hyperledger transaction. In the above example, John is initiating a transaction to send a message to Kat. Let's assume that we have a state in the ledger named as message, denoting the last message that had been sent and its store as a key value pair in peer of organization. Now, John has decided to send a new message to Kat and submit a request to the Node.js backend from the message dashboard. The Node.js SDK client takes this new proposed state and sends a proposal to all the endorsing peers of the organization as per the endorsing policy defined in the channel configuration, as well as confiding to the membership services. This includes a proposal request to invoke the corresponding function described in the chain code. The message thus gets verified by the orderer and finally gets committed to the CouchDB, thus confirming the transaction. Linux family. Hyperledger is a part of the umbrella project under Linux Foundation, where a community of developers work on open source projects. Linux Foundation provides infrastructure, services, events, training, and financial resources for creating sustainable open source ecosystems. Linux Foundation is known for its open source projects. Hyperledger is a consortium of organizations. It's not a blockchain platform. With Hyperledger, there are different blockchain projects. The original code for these projects was submitted by various companies like IBM, Intel, etc. Linux then made these codes open source to invite the entire community to work together and contribute to the codes. The vision was to create an enterprise-level blockchain platform. Hyperledger projects. Hyperledger umbrella strategy. Hyperledger nurtures a lot of blockchain frameworks and technologies under the umbrella strategy. Some of the well-known projects under Hyperledger are as follows. Sawtooth Lake. Hyperledger Sawtooth is a blockchain platform implementation which builds, deploys, and runs distributed ledgers. It is a modular platform which provides a digital record without a central authority or implementation. It is primarily used for supply chain networks. Fabric. Hyperledger Fabric's framework was contributed by IBM. Fabric works as a foundation for developing applications with a modular architecture. The framework utilizes container technology to host smart contracts, chain code, comprising the system's application logic. One of the examples where it is used is fishing industry to track the supply chain of fishes. Burrow. Hyperledger Burrow, hosted by the Linux Foundation, is a blockchain framework implementation. The framework was contributed by Monax and co-sponsored by Intel. Burrow is a permissioned smart contract application engine partially developed in accordance to the specifications of Ethereum Virtual Machine, EVM. It is used to run Ethereum smart contracts. Iroha. Hyperledger Iroha, hosted by the Linux Foundation, is another blockchain platform implementation. The framework was contributed by Soramitsu, Hitachi, NTT Data, and Kolu. Written in C++, Hyperledger Iroha incorporates a unique algorithm on chain-based Byzantine fault-tolerant consensus. It provides a small set of fast commands and queries covering most common operations for the digital asset and identity management. It can be used in mobile application organization. Indy. Hyperledger Indy is a distributed ledger and utility library built for decentralized identity. The distributed ledger provides tools, libraries, and reusable components to create and use independent digital identities based on blockchains. They are interoperable across administrative applications, domains, and any other silo. It is used as a decentralized identity database. Sawtooth. Hyperledger Sawtooth is a blockchain platform built for enterprise use where the design focuses on maintaining the safety of smart contracts and the ledgers are kept distributed. Sawtooth offers a simplified platform for blockchain application development by separating the application domain at the core system level. Application developers could opt for a language of their choice to write smart contracts logic. Following are some of the key features of Sawtooth: application layer in core system separation, parallel transaction execution, pluggable consensus algorithm, private networks with Sawtooth permissioning features, Ethereum contract compatible with Ceph event system. Hyperledger Architecture. Hyperledger blockchain network participants. Following are the different participants within Hyperledger blockchain. Blockchain user. A blockchain user performs transaction on the network. The user can invoke a function from the chain code in order to send the instruction message to the underlying network, which can then process the transaction. Certificate authority. The certificate authority ensures that only certain restricted parties can be a part of the business network on Hyperledger. They access security certifications in order to determine the parties who have required privileges to be an actor on a network. Traditional database. It is a standard database which is used to store data. Traditional processing platform. It stores access to the logical code written, which is used to run the network as per the design. Blockchain Development Network. It operates the blockchain network, which enables the execution of smart contracts chain code, as well as various transactions that take place between the participants, which are part of the network. Blockchain Developer. A developer develops applications on the blockchain using chain code. Currently, Hyperledger Fabric supports Node.js, Java, and Golang languages to write such chain codes. Regulator. Regulator runs oversight to ensure that the platform is operating without any bias. Hyperledger Architecture. Following are three main components of Hyperledger. Membership service. It is a set of cryptographic materials, certificates, that defines organization by itself. Every peer and orderer needs this type of certificate. This certificate has some common property by which we decide whether the peer and the orderer belongs to the same organization or not. A peer, which is a part of the same MSP, can communicate with each other. A peer from other organizations cannot be allowed to communicate with each other. Blockchain and transaction layer. This layer constitutes the core code of the blockchain. It comprises of consensus algorithm, which is required to make the final decision on the state of every transaction. It also contains the distributed ledger and ledger storage, which stores the entire history of the transactions and the last known states. Lastly, we have the P2P protocol, which is used for communication between different nodes on the network. Chain code. It is the logical programming layer which consists of the business logic required to run an operation on the Hyperledger. Permissioned blockchain and its consensus model. Permissioned blockchain maintains an access control layer and allows certain actions to be performed only by a few identifiable participants. It is also called private blockchain. Following are the properties specific to permissioned blockchains. It has legally accountable validators. It is suitable for off-chain assets. They can be used as an IT tool for settlement and clearing. Examples include Ripple, which determines roles for a select number of participants who can act as transaction validators on their network. Such blockchains are also popular among industry-level enterprises and businesses for which security, identity, and role definition are important. Permissioned versus permissionless blockchain. Let us see some differences between a permissioned and a permissionless blockchain. 1. In regards to access, a permissioned blockchain only allows pre-approved members to access the network and make transactions to it, whereas a permissionless blockchain allows anyone to be a part of the network as it is completely open and transparent. 2. Permissioned blockchain are faster than permissionless blockchain when it comes to performance, as they have less number of participants in the network. 3. Permissioned blockchain use different types of consensus algorithms like PBFT, proof of stake, and more. Usually, permissionless blockchains rely on proof of work. 4. The transaction cost in a permissioned blockchain is lower than that of a permissionless blockchain. 5. In regards to stability, permissioned blockchain are considered more stable compared to permissionless blockchains, as the former have a better governance due to known parties which are a part of the network. 6. In a permissionless blockchain, all participants have the same level of access, whereas a permissioned blockchain provides full access only to the members which are registered to be a part of the business network. 7. Permissionless blockchains work in a peer-to-peer fashion, relying solely on consensus algorithms to create a trusted environment. However, permissioned blockchains have trusted members as part of the network, which enhances the trust on the network. Consensus and its interaction with architectural layers. Consensus. Consensus is the process by which a network of nodes validates the block of transactions and provide a guaranteed ordering of transactions and validating those block of transactions that need to be committed to the ledger. Consensus must ensure the following in the network. Confirms the correctness of all transactions in a proposed block according to endorsement and consensus policies. Agrees on order and correctness and hence on the results of execution. Depends on smart contract layer to verify correctness of an ordered set of transactions in a block. Hyperledger makes use of the permissioned voting-based consensus from the pool of the other consensus named the lottery-based consensus. Consensus properties. Consensus must satisfy two properties to guarantee agreement among nodes: safety and liveness. Safety means that each node is guaranteed the same sequence of inputs and results in the same output on each node. The algorithm must behave identical to a single node system that executes each transaction atomically one at a time. Liveness means that each non-faulty node will eventually receive every submitted transaction, assuming that communication does not fail. Activities performed to reach consensus. Hyperledger frameworks reach consensus by performing two activities: transaction ordering, transaction validation. By logically separating these activities, we ensure that any Hyperledger framework can work with any Hyperledger consensus module. The first step of the consensus process flow is receiving the transactions from the client application. Consensus depends on an ordering service to order transactions. Transaction order enables confidentiality of the transactions. It also increases the efficiency of the transactions. To validate transactions, consensus depends on the smart contract layer because it contains the business logic behind what makes a transaction valid. Transaction validation contains business logic to make the transaction valid. It also ensures the confirmation of policies and contracts specified for the transaction. Then, it also checks for syntax and logic errors. Consensus model for permissioned blockchain. Consensus in Hyperledger Fabric, as seen in the image above, is broken out into three phases: endorsement, ordering, and validation. Endorsement is driven by policy, e.g., M out of N signatures, upon which participants endorse a transaction. Ordering phase accepts the endorsed transactions and agrees to the order to be committed on the ledger. Validation takes a block of ordered transactions and validates the correctness of the results, including checking endorsement policy and double spending. As soon as a new transaction is created, it is sent to the endorsement peer to generate a read-write pair. The read-write pair from every endorser is then sent to the orderer, which orders the same and generates a block based on consensus. The ordered block is then sent to the validator to update the couch DB with the most recent state. API and network topology in Hyperledger. API. It enables clients and applications to interface to the blockchains. Hyperledger supports the following types of APIs. Admin APIs. This class creates an administration connection to a Hyperledger Composer runtime. The connection can then be used to deploy business network definitions, undeploy business network definitions, update business network definitions, send a ping message to the runtime to ensure it is running and correctly configured, store a connection profile document in the connection profile store. Common APIs. They are used to obtain information about the connected networks. This information can include business network, metadata, enum declaration, and many more. Runtime APIs. These are used to perform all transaction operations like running a query, managing assets, and more. Network topology. Network topology is a technical infrastructure that provides smart contract services and ledger to applications. Listed below are the components of network topology. Ledger. A ledger consists of two distinct parts, a blockchain and the state database. Unlike other ledgers, blockchains are immutable. In contrast, the world state is a database containing the current value of the set of key value pairs that have been added, modified, or deleted by the set of validated and committed transactions in the blockchain. Smart contract. A smart contract is a code that is invoked by a client application external to the blockchain network. It manages access and modifications to a set of key value pairs in the world state. In Hyperledger Fabric, smart contracts are referred to as a chain code. Peer nodes. It is a network entity that maintains a ledger and runs chain code containers in order to perform read-write operations to the ledger. Peers are owned and maintained by members. Ordering service. It is a defined collective of nodes that orders transactions into a block. The ordering service exists independent of the peer processes and orders transactions on a first-come, first-served basis for all channels on the network. Channels. A channel is a private blockchain overlay which allows for data isolation and confidentiality. A channel-specific ledger is shared across the peers in the channel, and transacting parties must be properly authenticated to a channel in order to interact with it. Fabric certificate authorities. Hyperledger Fabric CA is the default certificate authority component which issues PKI-based certificates to network member organizations and their users. The CA issues one root certificate to each member and one enrollment certificate to each authorized user. Steps to create a Hyperledger network. Following steps should be followed to create a Hyperledger network. Step 1. Create a network. The network is created from the definition of the consortium, including its clients, peers, channels, and ordering service. The ordering service is the administration point for the network because it contains the configuration for the channel within the network. Step 2. Define a consortium. A consortium is comprised of 2 or more organizations on the network. Consortiums are defined by organizations that have a need for transacting business with one another, and they must agree to the policies that govern the network. Step 3. Create a channel for consortium. A channel is a means of communication used to connect the components of the network and/or the member client applications. Step 4. Join peers to channels. Peers are joined to channels by the organizations that own them, and there can be multiple peer nodes on channels within the network. Step 5. Install smart contracts. Smart contract chain code must be installed and instantiated on a peer in order for a client application to be able to invoke the smart contract. Step 6. Optimize the network. While there is no theoretical limit on how big a network can get, as the network grows, it is important to consider design choices that will help optimize network throughput, stability, and resilience. Step 7. Add another consortium definition. As consortia are defined and is added to the existing channel, we must update the channel configuration by sending a channel configuration update transaction to the ordering service. Step 8. Add a new channel. Organizations are what form and join channels, and channel configurations can be amended to add organizations as the network grows. When adding a new channel to the network, channel policies remain separate from other channels configured on the same network. Step 9. Add peer and join it to multiple channels. You can continue adding new peers and connect them to several channels within the network. Network topology. The diagram above shows a fabric network with the following configuration. There is a fabric network N with network policy NP1 and ordering service O. Channel C1 is governed by channel policy CP1. Channel C1 has been established by Consortium RARB. Channel C1 is managed by ordering service O and peers P1 and P2, and client applications A1 and A2 have been granted permission to transact on C1. Client application A1 is owned by organization RA. Certificate authority CA1 serves organization RA. Peer P2 maintains ledger L1 associated with channel C1 and L2 associated with C2. Peer P2 makes use of chain code S4 and S5. The orderer nodes of ordering service O are owned by organization RD.
Who is a blockchain developer? A blockchain developer is a person who is responsible for developing and hence enhancing blockchain-related applications, famously known as dApps, smart contracts, architecture, and protocols. For those who don't know what blockchain is a system of recording details of transactions in a block taking place in the blockchain network. That makes it difficult or impossible to change or hack, which means they are immutable. A blockchain is essentially a digital public ledger of transactions that is copied and distributed across the entire network of computer systems on the blockchain. Basically, blockchain developers enable secure digital transactions by creating systems and applications to record and store blockchain data and prevent external changes or hacks. That brings us to what are the types of blockchain developers. There are two types of blockchain developers: core blockchain developers and blockchain software developers. Each type has its specific type of role. Let's go through them in more detail. The core blockchain developers design the protocols required to run a blockchain solution successfully which means they are majorly responsible for the architecture development of blockchain. They are also responsible for designing consensus protocols and making high-level decisions. Blockchain software developers develop and implement the blockchain using the designs and solutions created by the core blockchain developers. They are majorly responsible for designing and implementing smart contracts and developing decentralized applications or dApps. Now let's understand what are the technical skills required to become a blockchain developer. To become a blockchain developer, you need to have a specific set of technical skills. Let's take a look at them. Understanding blockchain architecture. For starters, you should have a complete understanding of blockchain technology, its architecture, how it works, and its critical concepts like hash functions, distributed ledger technology, and consensus protocols. Next, data structure and coding. Data structures and coding are considered the most basic and essential skills required to be a fine developer. It is a must-have skill to become a blockchain developer, as it enhances your ability to play and configure blockchain according to your requirements. Development of smart contracts. Smart contracts is the most vital part of blockchain technology. The programming language Solidity is used to create smart contracts. Ethereum is the best example for smart contracts. It helps you set up the business and develop and deploy dApps using smart contracts. And at last, basic knowledge of cryptography. Blockchain secures its data by using highly effective cryptography algorithms. Cryptography helps you implement dApps and other blockchain services. Now we have covered the technical skills required to become a blockchain developer. Let's explore the roles and responsibilities of a blockchain developer. Both core blockchain developer and blockchain software developer have different roles and responsibilities. First, we will discuss the roles and responsibilities of core blockchain developer. Core blockchain developer understand and implement the features and functionalities of blockchain. They design protocols and consensus protocols for blockchain networks. They create solutions for providing security to the data stored in the blockchain network. And they make sure that the blockchain network functions smoothly and securely. Now, blockchain software developer design and implement smart contracts. They develop and deploy decentralized application or dApps as per the requirements. Also, they look after the integration with other applications and services. Now let's dive down and explore the companies hiring blockchain developers. There is a massive demand for blockchain developers, and if you know your skills well, you will surely get a good start with your career as blockchain developer. Joining a programmers community and working on real projects will help you learn, grow, and upskill yourself. According to 2021, SignSoft, a software development company, Ripple Labs Incorporation, an American technology company that deals with the Ripple payment, Leeway, a software development company for startup and enterprises, Chromaway, a blockchain technology company, OpenLedger, a decentralized financial platform used to convert bitcoins to smart coins, and IntellectSoft, a company specialized in providing software products and integrated solutions, are a few top companies who hired blockchain developers to work on blockchain technology. Now that we know about the demand of blockchain developers worldwide, let's figure out the average salary of a blockchain developer in both the USA and India. In the USA, the average salary of blockchain developer is over $157,000 per year. And in India, it ranges from 5 lakh rupees to 30 lakh rupees per year. So this is all about who is a blockchain developer. We have almost reached the end of this video. If I missed anything important, do let me know in the comment section. I hope you enjoyed this video on who is a blockchain developer and learned something new from it. If you like this video, then please do hit the like button. Thanks for watching and stay tuned for more updates and videos from Simplilearn.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.